Okay, so next is question number 3, which is very simple. If you have understood the previous question, you will understand this easily. Okay, so what it says, ABCD is a rectangle. So they have given a quadrilateral ABCD and they have said it is a rectangle. So from rectangle, what you understand, opposite sides are parallel and equal, right? Okay, and PQRS are midpoint. PQRS are midpoint of AB, BC, CD and DC respectively. Okay, show that the quadrilateral PQRS rhombus. So PQRS, you have to show this is a rhombus. So for rhombus, first thing what you have to show, all sides same, equal you have to show, and you have to show what, pair of opposite sides parallel. Okay, opposite sides are parallel, you have to show. Now see here, if you can show this one parallelogram, that you can easily show, right? In the previous question also you have done that. This I can show easily parallelogram. So once you show this parallelogram, what you can say, opposite sides are equal, right? Now you just have to show this adjacent sides also same. Okay, so first what I will show is PQRS parallelogram. So once you show parallelogram, again I repeat, opposite side automatically it will be equal. This and this will be equal, this and this will be equal. And in rhombus, what you have to show? What you have to show is all sides same. So just that you have to show. So for all sides same, we know that this and this same, this and this same. Just I have to show this and this same. Or you can say this two same, or this two same, or this two same. Any adjacent side you try to show same, your problem solve. Okay. So first I will show parallelogram. Then I will show adjacent, any two adjacent sides same. So how we can show parallelogram? So that is very simple, right? We need to draw diagonal using midpoint theorem. Remember, if in a triangle, this is a triangle, you can see when I draw the diagonal, this will form a triangle, and in this triangle, in this two sides, there is a midpoint. So if I join this midpoints, whatever line it form, it will be always parallel to the third side. This is the theorem. So if this and this parallel, same way in this triangle also, this and this will be parallel. So this parallel to this parallel to, so obviously this and this will be parallel. Similarly, this and this will be parallel. So it will form a parallelogram. So opposite sides are same, that we can say. Okay. Next, to show adjacent sides same, very simple. They have said this is a rectangle in which these are the midpoint. So if these are the midpoint, now see first thing. This is a rectangle means what? This side and this side same. And this is midpoint, this is midpoint. So obviously this and this also must be same. Simple. Same way here, this side. In this side you don't need it. Directly you can say this side and this side is already same. Because this is the midpoint, right? So you can see in this triangle, I just have to show this and this equal, right? In this triangle and this triangle, I can show this two triangle congruent. So once you show this two triangle are congruent, what you can say? Corresponding part of congruent triangle, this and this will be equal. Simple. Okay, so basically first part it's you have already done. The second part only is you have to show adjacent. Suppose I want to show this two sides same. What I will do is I will use this triangle, I will use this triangle. And how I can judge all this? The reason is I know I have used congruent triangle many times. The moment I have seen that I have to show this two equal, I thought based on this which triangle it is there. This one and this one. Then I need to think whether I can show this two triangle congruent or not. If I can show congruent, then I can easily say this two same. This way you have to analyze from the diagram, okay, whether you can show this one equal or not. If you want to show it, how you will do it? Where the triangle is included, you try to see that and try to show congruent, you can easily show equal. Okay, so in rectangle ABCD, AB is equal to CD is equal to and BC is equal to AD. This is the definition of rectangle, right? PQRS capital letter RS are midpoint of ABCD. AB, BC, CD. According to question you write down. Okay, these are given information I have written. Now I will show PQRS parallel. So for that I have to do construct diagonal, like previous question, diagonal AC and BD. So in triangle, which triangle you will take first? Again I repeat, from the theory you will not understand anything. If some students are there who thinking that I will write down this one and I will try to understand from here. Trust me, every question you will find it difficult like this. Always try to see the diagram, and from the diagram itself, first think how you will find out solution. So once you understand that, those things only write down here. Okay. So first I made an aim on this diagram only how I will find the solution. So once I got the idea, those things I am interpreting here. Okay. So construct diagonal AC and BD. AC I have drawn. So let me draw here with dotted line. Okay. So in triangle, which triangle you will take? BAC or ABC. In triangle ABC, P and Q are midpoint. So if these are midpoint, can I say this side and this side will be parallel? Because theorem says that in a triangle, two sides of a triangle, if you draw a line from the midpoint, that line will always be parallel to the third side, right? So what I can write here? PQ parallel to AC. Directly can I write? Why? Midpoint theorem. Okay, midpoint theorem. Next, similarly, SR can I say parallel to AC? SR parallel to AC. Again, midpoint theorem. Okay, so I have shown this and this parallel, this and this parallel. So if this parallel to this parallel to, can I say this and this parallel to this? Therefore, PQ parallel to SR. So this I have proved that this and this parallel. Now I will show this and this parallel, that we don't have to show. Similarly, you can write PS parallel to QR. So if this and this parallel, can I say it is a parallelogram? So therefore, I can write PQRS is a parallelogram. So from this what I can write? Therefore, PQ is equal to SR and opposite sides are same. QR is equal to PS. But I have to show all this are same. All sides same you have to show, right? Then only you can say it is a rhombus. Now opposite side I have already shown it is same. Now I will show adjacent side. This and this same. Once you will show this and this same, automatically this will be same to this, because this and this are same, right? And this same, and this same, we know that. So if you show this and this only, if this is equal to this, then obviously this will be equal to this also, because this and this also same. So all side will be same. Okay, so only adjacent side I have to show same. So for that, which triangle I will take? Again, in triangle, can you see how I'm writing the theory here? First I have tried to understand from the diagram itself how I will find the solution. So those things simply I'm writing here. Okay, so in triangle PBQ and QCR, what I will do? PB is equal to RC. If you have confusion, draw separately the diagram. This triangle and this triangle. Okay, this is your PBQ and this is your RQC. So in this triangle you can see this and this sides are same, this and this side same, right? And since this is a rectangle, can I say this and this same? This and this same. 90 degree, right? So let me write down angle B is equal to angle C, 90 degree each. And this one given. Condition you have to write, okay, why you are writing equal. Next, BQ is equal to QC. Given this also, right? Therefore, triangle PBQ is congruent to triangle, which letter you will take? RCQ. RCQ. Therefore, can I write PQ equal to RQ? Why? CPCT. Okay, CPCT. So from this, can I say therefore PQ is equal to SR is equal to QR is equal to PS. PQ is equal to RQ means what? PQ is equal to RQ. This and this equal. This and this equal means what? This and this also equal. This and this also. So all are equal. Therefore, PQRS is a rhombus. Okay, done. Proof.